Becoming a data engineer is pretty much easy. All you just need is Python and SQL, and that's it. You're a data engineer. Apparently, you need more than that. In today's video, we are going to be taking care of what it takes to become a proficient data engineer and some of the things you're probably going to need, especially when you want to embark on your journey of upskilling yourself from a data engineer that is a total beginner to a more proficient and expert data engineer that is able to command higher salary in the job market. So let's get into it and see what that looks like. This is a 10-step roadmap to becoming a proficient data engineer by working on projects. This video is sponsored by Data Mastery Lab, an online learning platform that is focused on equipping data professionals with practical, job-ready skills in the fields of data engineering, data science, analytics, and artificial intelligence. Some of their core offerings include expert-led, mentor-guided courses, hands-on projects and real-world capstone work, AI-powered job matching and career support, enterprise and team training plans, as well as cloud and big data focus. They have a catalog of over 100 self-paced courses and learning paths that is covering foundational through advanced topics like SQL, Spark, Kafka, DBT, and so much more. They also have specialized tracks for AWS, Azure, GCP, alongside modern architectures like serverless streaming data lakes that prepare learners for current industry demands. In short, Data Mastery Lab helps both individual and enterprises build and certify critical data capabilities through structured curricula, real-world practice, and dedicated mentorship. The first thing you need to do before you get started is understanding your programming and data foundations. So you need to understand Python, object-oriented programming, and some additional libraries like the math library, the pandas library, the numpy library, and so much more. So a couple of these will ground you and give you the understanding and the basics that you need to help you ingest data, transform them, and load them if you so wish into some destination. So as a total beginner, you don't necessarily have to end-to-end do all of this, but you need to understand the basics of object-oriented programming like classes, functions, modules, and how to use several libraries, installing them, getting everything ready and set up on your environment. These are the things that you need to get you started with Python and some of the libraries that are going to be required. Now, if you're a Java enthusiast and you are interested in compile time savings and some of the additional benefits that comes with that, you probably need to look into Java. So you need to understand the Java object-oriented library or object-oriented programming and some of the libraries that are going to be used to facilitate this process. If you understand Java very well in terms of OOP level, understanding the data types, the variables, the way you write the syntaxes, and the object-oriented parts like classes, abstractions, encapsulation, polymorphism, and stuff like that. If you understand them to some high-level degree, not just an absolute total beginner degree, then it should be way too easy to take on something like Apache Flink and even Scala to work on data engineering projects. Now, aside from that, you need SQL. This is a no-brainer. These two are the fundamental foundations to data engineering, either Python and SQL or Java and SQL, or the combination of the three. So if you have SQL, you need to understand everything about, well, maybe not everything, but at least to some high level degree, you need to understand things like the SQL syntaxes, the joins, the groupings, the aggregations, the windowing, and stuff like that. Now, I know there are a lot of tools out there that help you to abstract all of this away from you, just drag and drop. This is not going to be beneficial to you as a data engineer, especially when you're just starting. If you are an expert or you are proficient enough in these rudimentaries, then it is going to be easier and make your work faster to do drag and drops. But before then, try not to skip the basics. try to understand what SQL is, what Python is, or what Java is. Now, these three are going to be your rock solid foundation that you're going to be needing, especially when you want to become a proficient data engineer. Now, there's something called Git. If you are not aware of it, it's for versioning. So think of you doing something and you lose access to it. Git enables you to keep track of those things and prevent you losing your work. So if you have a version that is working and you commit that, you can easily refer back to it in case anything goes down, your system crashes, your network goes off, or whatever it is, and you lose access to the file. If you already have it in your Git version, and it's going to be easy to just switch multiple versions of the same project. So try to understand what Git is about. Then you need some Linux basics. Now this is because it's a foundation, so you need to understand how to work with Linux command, basic Linux command like listing a directory, moving a file, copying a file, using Vim. I myself struggled with that before, and I had a friend that challenged me to work with Vim. So he opened a Vim when I was starting my career more than a decade ago. So he opened Vim and asked me to close it. I was like, I can only type, I can't even close it. What did you do? And stuff like that. But it was really interesting. So as a beginner, absolute beginner, you need to understand the basics of Linux. Yeah, you don't have to know how to install Linux to be able to work with it. You can easily spin up an EC2 instance like Ubuntu or Amazon Linux or whatever it is, just to be able to practice all these things and understand how to work with it. So some of these syntaxes, and you can also get some cheat sheets that can help you get way faster with this Linux basics. So this is a no-brainer. You are gonna need them, especially when you want to deploy your applications and stuff like that. These Linux basics that you already learned is going to be very much helpful at that point. Now, in terms of the project, if you understand all these 5 things, maybe 4 of them, if you understand them and you understand them very well, these are the projects that you should take care of. So you should be starting with data cleaning with pandas. So if you already know the Java OOP, Python OOP libraries, OOP and the libraries that are involved, something like pandas should come out of the box right away. Then you should understand how to work with pandas. In this case, you can also pick up some query challenges with sample data sets. You can go on something like LeetCode to practice all these things, so you can get better at querying SQLs and all that. Well, this is subjective, but there are some people that say LeetCode is bad, but I think it's going to be giving you the muscle memory that you're going to be needing in time coming in the future. So yeah, you should also build something like a CSV, a CLI CSV parser, where you open your Python terminal and you point your path of a CSV to it, and then it helps you pass the CSV, present something in the output, just to form something like fun and little games to get you started with Python or data programming essentials. Number 2 is data modeling and relational databases. Now you've gotten away with the Python basics, the Java basics, and SQL. You understand those. Now you probably don't understand fully what a data modeling is or relational databases, but you can query, to some extent. Now, the number 2 thing you need to do is understand how to model data and relational databases. So some of the things that you are going to be needing is entity relationship modeling, where you have the classes, the tables, and the relationships that are going to be related to that table, like the columns, the private functions and stuff like that, stuff procedures. All these things are some of the things that are going to be infusing into your ER modeling. And by the time you understand this, it's going to be way easier to even pick up something like normalization, where you have the first normal form, second normal form, third normal form, fourth, the BNF and all that. So check all of this normalization as well. It's going to help you to understand and how best to work with your data, especially when it comes to something like reporting, where you don't want to have the repeated data. Sometimes it's required, but in some cases you want to have your data in normalized form in this case. Now, one thing that is going to be interesting to you to know is PostgreSQL is an open source, so most data engineers, this is going to be like the minimum bar you can use to enter the job market as a data engineer. So you need a PostgreSQL understanding, which is easily transferable to something like other RDBMSs like SQL Server, Oracle, and the rest. But you need to understand what Postgres is all about, how it works, some of the optimization techniques and stuff like that that you can use with, that you can do with it, and how to model data with Postgres. Then things like indexing and partitioning are something you want to pick up as well. These are the ways you can fine-tune your data to make it faster, much more fault tolerant and more resilient, especially when you have millions or even billions of data as they come in. So if you understand all of this, then it's going to be easier to pick up some of these projects that I'm going to be mentioning shortly. So you need to start with something very simple, not too simple, but creating a relational database for an e-commerce system. Now, to create this, it's going to be a little bit more challenging because an e-commerce system, you have products, you have orders, you have inventories and stuff like that. How do you model them? How do you create a visualization on top of this to be able to have an enterprise ready system or production ready system? It's going to be a little bit challenging, but I guarantee you, if you're able to do this and you put your mind to it, it's going to be way easier, especially when you get to a little bit more complex systems. Then you need to run complex analytics queries. This is a no-brainer because if you have an e-commerce system, you populate it with some dummy data. You can run complex analytics, try to understand what the daily sales is, the weekly average sales, the top performing products, the top performing customers, customer churns and stuff like that. You can easily get all of these with some complex analytics queries. But all of these are building on top of the foundation. You guessed this, right? So if you do not know Python or you do not know SQL, at this point, it's going to be way difficult for you to understand the ER modeling, relational databases and some of these projects to be able to carry them out. Well, you can ask ChatGPT or any other AI out there, but it's not going to help you in the long run. All right, so the next thing you want to do is data warehousing, which is the third thing in the third step of becoming a proficient data engineer. You need your data warehousing and NoSQL. Now, NoSQL is arguably, you don't necessarily need it, but data warehousing, you definitely need it. And it's simply because if you're working in a complex, an enterprise environment, you probably have millions or even billions of data that you're working with. Data warehouses allows you to traverse this data and understand the behavior of your customers, the behavior of your products, and things that you're providing to the services you're providing to your end users. So if you understand what data warehouses are, then the entity relationship diagram and modeling that you already did before, creating a simple e-commerce application, you can easily leverage that knowledge when it comes to the data warehousing. So you need star schema or snowflake schema or some other types of data modeling in this case, but you understand what I mean. If you try to get your ER modeling in place, just try to apply the star schema approach or the snowflake schema approach on top of that data warehousing data, and you're on your way to becoming a proficient engineer. So you need something like Redshift, BigQuery, or Azure Synapse Analytics. You need Cosmos DB, MongoDB, for the NoSQL part. And the reason for that is you don't necessarily need the MongoDB part, but when it comes to some other projects where you need to do some document related approach systems, then you need to understand how to work with MongoDB, because it's a little bit different. The concept is similar, in terms of like tables and columns and stuff like that, but the fundamentals, the fundamental concept is a little bit, it's a paradigm shift, especially when it comes to document databases and relational databases, which is why it is called NoSQL, because in this case now you are not conforming to any particular schema, but for you to have an enterprise related system, you need to conform to some certain standards, especially in NoSQL world. All right, some of the projects that you can do on this end are something like build a star schema, like I mentioned, or a snowflake schema, then load the data and query them with BigQuery. You should store the data and in JSON, in MongoDB, export the data from something like using something like Python. Yeah, you can easily read the data and dump it in MongoDB so you can understand what version of this data look like in the document world, in document DB, because MongoDB is document based. All right, so the number 4 things that you need is the ETL or the ELT. Well, essentially people are saying you no longer need the ELT, ETL, but I'm of a different opinion. You definitely need this. Now, you cannot be a proficient data engineer without understanding the legacy systems. So all these are, legacy systems, especially the approach of ETL and ELT in this case, because you fundamentally you extract some data, transform them, then load them somewhere, which is essentially what you need. Even with the latest advent of things that are changing, like one site clicks, it's still the same process. Regardless, if you have a system as simple as it is, you still need to extract the data, and then you can now perform some transformation on it, or you load them to some data warehouse, then perform some transformation on it. Regardless, you're still going to need the ETL, but in this paradigm it's going to be way abstracted. So ETL might be at the bottom, then you have some abstraction on top of it and some other systems on top of it to make things way easier. Maybe one click, something like if you point to your S3, you read the data automatically, do some automatic AI stuff on it, and then present the data by reading it. So it's still like the fundamental is the same. Yeah, extract, do the transformation, and then load it somewhere, transform it, and present the results somewhere. So this is really, this concept is not going away anytime soon, but it's still a legacy approach, especially when you are using some old versions of the tools that are required in this case. So you need to understand what ETL is versus what ELT means, and how to work with something like Python to facilitate your ETL process. You need something like DBT, especially when you're working with multiple databases or something like a business-oriented systems. Then you need, if you're migrating data or you want to schedule data dumps on a regular basis, you need something like Airbyte. If you're working on the cloud, you need Glue or Azure Data Factory, where we're going to get to we're going to get to the cloud bit shortly, but for now you need something like Glue and Azure Data Factory. So if you don't know what they are, you're probably going to in a short while. So you need connectors, and the reason for these connectors, I intentionally put it here because these connectors, some of these systems allows you to automatically connect to them. Things like Kafka, think of it, you have Kafka connectors, yeah, which automatically dumps the data, so you don't have to necessarily worry so much about the loading part. So you just need to extract and do the transformation into Kafka, and Kafka loads it automatically. So that is why it is in this area. Some of the projects that you can do in this case when you are building your data pipeline is something like ingest CSV API, clean the data with pandas, and load into Postgres. As simple as that. Or you can use something like DBT to do the transformation. So you load your data into instead of the transforming bit, which is this guy, cleaning your data with pandas, you probably load it into some data warehouse. Then you connect your DBT to that, which you can use to now do the transformation and load the data into some other tables, some fine-tuned tables and fine-grained them. Then you need, if you are doing something like data migration, you definitely need Airbyte. And then if you are doing data ingestion and transformation, you can use something like Glue or data factories or Fabric in this case. If you are on the cloud, you can also use the Google Cloud versions of Dataflow as well. Number 5 thing is workflow orchestration. This list is never going to be complete without workflow orchestration, because most of the things that you're doing as a data engineer revolves around orchestration. So you want to have some defined steps that you want to present your data in. So you need something like Apache Airflow in this case. Understand what DAG is. No, not only Apache Airflow is using DAGs, so you need to understand what DAG in itself means and how Apache Airflow helps you to facilitate that piece. You have something like ADF triggers if you're on the cloud. You have logic apps on Azure, the scheduling, alerts, and notifications. All these things are some of the things that you're probably going to be needing. And in terms of the project, you need Apache Airflow DAGs that is going to be doing with daily weather ETL. So you extract daily weather and then load it into somewhere, connect it to some if you like Slack, Teams, or even something like Teams Webbook, or you use something like a Telegram API, or even SMSs, email, things like that to get daily weather data. And in this case, you are going to be exposed to something a little bit more than you thought, because as simple as this is, getting a weather API, passing the data and pushing the data to some extent to some output location like a sink, in this case like notification channels and whatever it is. If you are able to do this kind of project, it's going to give you some confidence to take on more projects, and these are just things that you can do alongside. So you should try to write your DAGs with retry logic, Slack alerts, some advanced functions. And the latest version of Apache Airflow that just came out, Apache 3.0, is a game changer, because if you are just getting started, you probably don't know the struggles that your seniors actually went through when you just started working with Apache Airflow, especially in version 1 or version 2. Now in version 3, all of those things are taken care of, so you should definitely check it out. So if you are checking something like ADF out, Azure Data Factory, try to automate the pipeline, schedule it, trigger email alert with something like logic apps. If you're using Google Data Flow, it's the same thing. You can easily just get your data source in, transform it, load it into somewhere, and trigger some scheduling, some notifications and alerting in there as well. Now, the batch processing system of big data is going to be in the number 6. This is probably one of the favorite things that you're going to be working with. You need something like Apache Spark Resilient Distributed Data Sets, the RDD. You need the Spark SQL, how to work with it. And if you notice something, we are seeing some repetitive patterns here. Yeah, in this case, if you don't know what SQL is and you want to work with Spark SQL, you're going to struggle. And this is what I tell my students: when you're working with something like Spark SQL, the basic understanding that you already had, which is the foundation that you did in number 1, which is the SQL bit, is going to be playing and shining your light on you at this point, because right now you're no longer thinking about what is a table, what is a partition, how to index a table and stuff like that. You are now thinking in terms of how to work with Apache Spark and using the Spark SQL API to query your data, the millions or even the billions of data that you're working with. So in this case, your SQL foundation is going to shine here, so which is what you need. And you need to understand what the concept of distributed computing is and some of the projects that you can work with. Something like using PySpark to process the NYC taxi or the clickstream logs. These are open source data sets that you can ingest into Apache's PySpark and use that to query the data. It's going to be fun, interesting episode to understand what the project, some of these projects that you can work with, especially with PySpark or Apache Spark in this case. You should try to analyze 10 plus rows, get some Parquet file, try to analyze the data, use Spark SQL in this case. If you prefer, you can use the Spark API as well, which is the Python API, or more, something like you should try to do something with Azure Data Lake Gen 2, especially with PySpark. This is something that you're going to be developing your muscle memory on, and it's something that is going to be interesting. I can assure you of that. Number 7, which is the next thing we're going to be discussing, is stream processing and messaging. Well, you probably know what you need here is Kafka. Now, before now, you need something like a publisher subscriber, something like queue, like a RabbitMQ would work generally, but it's still not as production ready in some sense, or as enterprise friendly, especially when it comes to the functionalities that Kafka brings to the table. So you should probably save yourself some time and learn Kafka instead of the RabbitMQ. You can learn RabbitMQ or other queue based system like that much later, but Kafka is something you want to look into and try to understand what Spark streaming is, especially how you connect your Spark with from Kafka, and then how to read data in real time from there. Of course, you need to do you can also do batch processing using Spark and Kafka, but try to leverage the streaming bit as well. Then you need Flink SQL. So if you are interested in the Java aspect of the data engineering, you need Flink SQL in this case to get you through. Then you need this Flink API, the windowing and aggregations, timestamps and all that. You need them here. These are where you handle some late arrival and how to best process and with the retry logic and all that. Then some of the projects you can work with here is something like Kafka to Spark, something like log processing. Because Kafka is append only, so if you keep writing data, you just keep appending them. But Spark in this case can help you to aggregate the data in real time over a window, and then maybe if you like, dump it into some data warehouse, some DB or wherever it is, or something like Superset or whatever. So in this case, you can create a dashboard using something like Streamlit to create a dashboard for the Kafka consumer. In this dashboard, you can easily just have a real-time dashboard on top of that. Then you can use something like Flink SQL to use real-time transformation pipeline if you're interested in the Java aspect. You also have something like Azure Event Hub, where you can easily push data into Event Hub on Azure. It works similarly with something like Apache Kafka in production. So it's just like you produce data into that. So if you produce data into Azure Event Hub, you can easily use something like Azure Databricks, which is leveraging something like Apache Spark under the hood to do some real-time transformation. Then number 8, which is the next thing you need, is cloud and data engineering on cloud. So now you've left your on-premise data. You want to go into the cloud to become more proficient on the cloud. So these are kind of the things that you need. You need something like S3, Delta, Data Lake, storage containers. You need GCS, Google Kubernetes Container Service. You need Redshift in this case on the cloud, BigQuery on the cloud, Fabric, ADL, Glue, Google Data Flow, IAM and stuff like that. Firewalls and all these things are some of the things that are going to be on the cloud. So your cloud fundamentals are going to be kicking into the picture now, because if you do not understand the cloud fundamentals, you're probably going to be struggling a little bit when it comes to working with some of these technologies. So you need to build a GCP data pipeline using something like the publisher subscriber, and then you publish into data flow, then data flow into BigQuery if you're working on the Google Cloud bit. And if you're using something like AWS, use something like AWS ETL with S3, Glue, and Athena. So S3 is where you store your data, Glue is where you do the transformation, and Athena is the visualization bit where you try to query your data that is already on Glue. Of course, if you're using Azure in this case, you can use something like Azure Data Factory or the Fabric in this case to facilitate some of this the ETL process. So the same thing, you store your data in the Azure containers, the storage containers. Then from there, you put your data into your transformation logic into ADF or Fabric, and then you load the data, and or use something like Synapse Analytics for the visualization bit as well. Now, the number 9 thing that you need is DevOps and infrastructure. Now, at this point, you are becoming, you've left the intermediate aspect. You are now becoming an expert at this point, because the DevOps bit is something that is generally not recommended to the beginners. So you need to have some understanding, the basic understanding of the beginner and some intermediate level understanding to be able to effectively work with the DevOps bit. So what are some of the things that you need? You need something like GitHub Actions. This is something that is going to be life-changing, because now you don't have to worry so much about your deployment. It happens automatically. Or if you want to use something like Terraform to do your deployment, you can easily use Terraform in this case. Then you have Circle CI, Jenkins, Argo CD, etc. that can help you do your CI/CD pipeline. So if you're using something like Kubernetes, Argo CD is your go-to tool. If you're using other tools like you want to connect your GitHub, not GitHub Actions in this case, you can have a Jenkins server that is listening to live actions from GitHub and building and deploying your application into some other destination. You have similar things with something like Circle CI as well. Then if you're working with something like Azure DevOps, you can easily do some of these things as well. Some of the projects that you can do in this case are you try to Dockerize Airflow, Postgres. If you've been watching the YouTube channel or some things, you can, or some Medium articles, you can easily just get yourself familiarized with how you can work with Airflow and Postgres and things like that in the DevOps world. Then you have something like Terraform to deploy into Azure Data Factory or AWS or any other cloud providers in this case. So we've worked with Azure in the past, we've worked with AWS and even Google Cloud as well. Especially you can work with them and transform the data, do the infrastructure as a code with Terraform and then deploy it into that. Then the final thing I think you need here is the CI/CD pipeline with something like Azure DevOps. Is something you want to take a look at and understand some of these ways you can work with it. Now drum roll for the final bits and things to cap it up. Now the last thing here is the Capstone project and portfolio. Now that you understood what it takes to become a data engineer in terms of the beginner aspects, the intermediate, and some of the expert and advanced bits of it, you now need to cap it all and package everything to be more professional in this case. Some of the things that you need in this Capstone project and portfolio are the documentation. So the code that you now write as an expert data engineer or a proficient data engineer in this case, you have a little bit more documentation, especially for people that are going to be onboarded into your project. Documentation is key. Readmes, having something like a dedicated documentation for the entire workflow, something like the high-level architecture, how each of the functions work, some of the things that you're going to be needing, the keys, the API, and stuff like that are going to be required. You don't document, you don't put your live keys in there. I mean, just like a placeholder to understand you need these keys from here and stuff like that. Something like that is what you need in the documentation. Then you need something like GitHub or GitLab or whatever it is, some kind of Git version in this case. You need them. In this case, GitHub is the de facto go-to, but you can use something like GitLab as well to do this. Then you need a resume. If you're looking for a job, then you need a resume, of course. But if you want to, have your own startup, then you probably don't need a resume in this case. Then writing some publications. Writing is a way to just put your thoughts into words. Yeah. In this case, you use a pen and paper, or you use your laptop to do the documenting of your journey, of your project, of your publications, or whatever it is, just to like put it out there so you can expose yourself and people can know that this person understand what they're doing and they can handle some of these advanced bits as well. Then some of the capstone you can do if you're working with something like Azure, use something like Event Hub to Spark to Synapse, then to Power BI. Or if you want to work with something like a full pipeline, you have Kafka to Spark, then to Spark, from Spark to Redshift, from Redshift to Superset. And this is agnostic of whatever cloud you're working with. It could be maybe from Spark to something like Snowflake, or from Spark to Postgres hosted on the cloud, or whatever it is. The pipeline, it doesn't have to be this. You don't have to use this standard approach. You can get some inspiration from YouTube, from Medium, from any other places online, just to get get your pipelines in place. Then finally, you need to document and try to demo on GitHub, LinkedIn, because of the SEO. So in case people searches for, look through your profile, they can see that you've done some project, properly document them, put it on GitHub, on LinkedIn, so people can, the Google search engine and other search engines can pick it up and attribute them to your profile, and people can, recruiters can easily see you or expose your your project on these platforms. Essentially, these are some of the things that you require. Now, for some of these projects, so this is a one-size-fits-all, like I mentioned. So for more tailored version of this project, then you need to check something like Data Mastery Lab, where you do skill assessment. So if you are an absolute beginner, then you want to do some skill assessment on what your skill sets are, it is currently, and some of the things that you already know. If you are coming from the industry, if you are just trying to break totally into the industry, regardless, you have some skill sets that you can leverage, especially when it comes to data engineering, that you can easily transfer across. Some of these things can be assessed using Data Mastery Lab skill assessment, and you're going to get a report, some of the recommended projects, some of the learning tracks that you can take, some of the projects that you can take and do as well, that is going to be increasing in complexity, of course, that takes you from a beginner, absolute total beginner, to your expert level. So what if you're somebody that is you already have some experience, especially maybe a 1-year experience, a 6-month, 3-month experience, maybe with Python or SQL or whatever it is, just take your skill assessment. If you take a skill assessment, then you can easily understand what maybe you are a beginner, you are intermediate in SQL or Python or whatever, or an expert, or whatever your level of experience and exposure is. You can easily do the skill assessments. Once you perform the skill assessment, then you can, your target is going to be the expert, of course. Then try to put in some goals, like you want to get a job, you want to upskill yourself, get some certifications and stuff like that. All this information are going to be taken care of by our AI powered system. Then you can generate a robust learning path for you that you can use, that is more tailored towards you, and get your project in place. So essentially, that's all you need to do. And thanks so much for watching. If you have not subscribed to the channel, don't forget to like, comment, share, and subscribe. And stay tuned for latest updates. Don't forget to turn on the notification bell, so you'll be the first person to get notified the next time videos are going up on the channel.